There's a star 642 light years away. It is massive and visible with the naked eye every night, but it is unstable, and any day now, whether tomorrow or 100,000 years from now, it will explode. It will go supernova. This is Betelgeuse, one of the brightest stars in our night sky, and perhaps one of the closest supernova humanity will ever witness. But will we live long enough to see it? Betelgeuse is a red supergiant among the largest types of stars in the universe. Roughly 700 times the diameter of our Sun, it is so vast that if you replace the Sun with Betelgeuse, its surface would reach past Jupiter. But that size comes at a cost. Massive stars like Betelgeuse burn brighter, faster, and die younger. It is only about 10 million years old, just a fraction of our Sun's 4.6 billion year lifetime, yet it's already nearing its end. All stars begin the same way, from clouds of gas and dust collapsing under gravity. But what happens next depends on the star's mass. Small stars, like our Sun, burn slowly and live for billions of years. Massive stars, like Betelgeuse, burn through their fuel quickly, fusing heavier and heavier elements at their core. Eventually, these heavy elements begin to choke the star's ability to generate outward pressure. And when iron forms, the game is over. Iron cannot be fused without consuming energy. The core collapses under its own gravity, triggering a violent supernova explosion that ejects the outer layers of the star in a matter of seconds. In late 2019, astronomers noticed something strange. Betelgeuse started to dim rapidly. It lost over 60% of its brightness within a few weeks. Speculation exploded across the astronomical community. Was this the beginning of the end? Was it about to explode? But deeper analysis revealed a massive cloud of dust had been expelled from the star, cooling and blocking much of its light. Even so, the event was a stark reminder. This is a dying star. Its surface is unstable, its internal processes chaotic. And one day, the dimming won't be temporary. In its final days, Betelgeuse would be fusing silicon into iron, a process that takes just days. Once a critical mass of iron accumulates, the core collapses in milliseconds. Temperatures spike to billions of degrees. Neutrinos burst outward. The outer layers crash inward, then rebound in a colossal shockwave. This is a core collapse supernova, one of the most violent phenomena in the cosmos. For a brief time, the star will outshine an entire galaxy. It will release more energy in seconds than the Sun will emit over its entire 10 billion year life. If Betelgeuse exploded tonight, a brilliant new light would appear in our sky. The supernova would rival the full moon in brightness, visible even during the day and casting shadows at night. No telescope needed. Anyone, anywhere on Earth, would be able to see it. And it wouldn't fade quickly. For weeks, perhaps even months, it would remain visible, gradually dimming as the energy from the explosion dispersed. Naturally, the idea of a nearby supernova raises concerns. Could it harm Earth? Fortunately, no. Despite its incredible power, Betelgeuse is far enough away that we're safe. At 642 light years, the dangerous radiation, gamma rays, and high-energy particles would be too diluted to affect Earth. There would be no extinction event, no ozone layer destruction, only light and knowledge. Humanity has witnessed stellar deaths before. In 1054, Chinese astronomers recorded a star that shone during the day for over 3 weeks, a supernova 6,500 light-years away. In 1987, astronomers observed SN 1987A in the Large Magellanic Cloud at 168,000 light-years, but none have occurred this close in modern times. Betelgeuse offers a once-in-a-civilization opportunity, a naked-eye supernova in our cosmic neighborhood. If Betelgeuse explodes while we're watching, it will become the most studied stellar death in history. Telescopes, radio, optical, X-ray, and gamma ray are already observing the skies. Space observatories like Hubble and James Webb are collecting baseline data to enable immediate comparison. Neutrino detectors, buried deep underground, could detect the explosion hours before the light reaches us. It would be an unprecedented chance to study the birth of a neutron star, or maybe even a black hole. Long before telescopes, Betelgeuse was known to ancient cultures. In Egypt, it was tied to Osiris. In the Pacific Islands, to warrior legends. In every era, people looked up at this bright red star and wove stories around its fiery glow. Imagine those stories reborn, not just in myth, but in memory as we witness the star's final act. Here's a mind-bending thought. If Betelgeuse explodes, we won't see it until 642 years after the event. Our view of the universe is always delayed. It may have already gone supernova, and we just haven't received the light yet. We are spectators in the cosmic past. Astronomers believe there's only a slim chance that Betelgeuse will explode within the next century. Some models suggest a 1 in 10,000 chance in our lifetime. But those odds, however small, are not zero. We are watching a ticking clock whose hands are hidden, and nature doesn't always follow a schedule. When it does explode, Betelgeuse will leave behind a compact remnant, either a neutron star or possibly a black hole. The explosion will forge heavy elements, gold, platinum, uranium, scattered into space. Those atoms may someday become part of planets, oceans, or even life. We look at stars not just for science of it, but for meaning behind it. Betelgeuse reminds us that even the brightest, most constant things are temporary. And if we're lucky, if timing and nature align, we may be one of the few generations to witness the death of a star with our own eyes. So tonight, look up, find Orion, and know that the red dot on his shoulder may one day become a beacon in the sky, a brilliant, final farewell from a dying giant.